In turn-of-the-century Berlin, the mysteries of the Earth begin to intrigue another scientist. His name is Alfred Lothar Wegener. The son of a strict Protestant minister, he forsakes family tradition to become a professor of meteorology. One Christmas, he receives an atlas and begins to study a map of the Atlantic region.
Wegener later told this story himself. He said, I started looking at it, and it was really odd. He said, I'd always noticed, like everybody over the age of 12 has noticed, that Africa and South America fit together. He said, but this map had information from deep down in the Atlantic Ocean, and what it showed is that that match between South America and Africa goes all the way along the continental shelf, all the way down to the foot of Africa. Now, if this is the case, he said, he thought immediately and pointed it out to his office mate, this isn't just an accident of sea level that these things look alike. These things look alike because they're connected in some way.
Almost as a hobby, Wegener develops a theory that the continents, once connected, drifted apart over time. But he's an experimental meteorologist, not a geologist. So he spends the next 2 years in Greenland, gathering weather data. He also sets a European endurance record for ballooning, and even proposes marriage in a balloon to Elsa Koppen, the daughter of his mentor at Marburg University. But his theory of drifting continents keeps gnawing at him.
Wegener's original idea about continental drift was a momentary intuition. For it to get to be science, you have to make the idea real.
There were particular kinds of fossils found only in certain parts of the world, which Wegener found very puzzling to explain how they got where they were. This one comes from Brazil. See, it's got a long fish-eating skull, a very long swimming body, and legs that look quite like paddles. But the only other place in the world where these animals have been found was in South Africa. And here is a specimen belonging to the very same species that was found in western South Africa. See here, it's got the same long, thin skull, paddle-like limbs and big, thick ribs. How could this be? These two areas are nowadays 5,000 miles apart with the Atlantic Ocean between them. So what could be the explanation as to how they came to be in those two places?
Wegener then learns that certain geological formations occur in very unlikely places. Far up the Arctic Circle, in the frozen islands of Spitsbergen, there are large deposits of coal. But scientists believe that coal is formed in tropical climates. Wegener also discovers that great rock sheets, the result of ancient glaciers, stretch for miles across tropical South Africa.
You can have glaciers in tropical areas if you've got very high alpine-type mountains, but not great extensive ice sheets, and that's what the evidence seemed to show. And so Wegener argued that those continents couldn't have been there when those glaciations occurred and had to have been either further north or further south.
Putting all the clues together, Wegener suggests that the continents were once joined in a massive supercontinent called Pangaea, or All-Earth. The continents must have moved throughout geological time, drifting across the ocean floor. Before Wegener can publish, war breaks out in Europe. As a reserve officer in the German army, he's called up to fight on the Western Front. Injured early in the war, before the worst of the casualties, he continues to work out his theory while his wounds heal. The result is the origin of continents and oceans, his argument for continental drift. Geologists are not impressed.
Many of them said disparagingly this was a theory of the Earth proposed by a weatherman, who moved continents around the way clouds move, but the Earth is this big solid thing. Continents don't just get up and skate around like pats of hot butter on a skillet.
They were able to show that when there was a major earthquake, the Earth just rang like a bell. It pulsated, and long waves travelled around the surface of the Earth for hours and hours after a major earthquake. Now, existing physical theory said that anything that was strong enough or big enough to behave that way when there was an earthquake had to be far too strong to allow continents to move round at the surface.
The soft underbelly of Wegener's 1915 theory was the fact that he did not have a force by which to split Pangaea and then propel its pieces across the face of the globe to take up their positions as the modern continents.
Wegener didn't know what made the continent move, and frankly, I don't think he thought that was his problem. He felt that that was something that other people would have to work on.
In 1930, Alfred Wegener leads a new meteorological expedition to Greenland. He's undaunted by the negative reaction to his theory and has updated his book several times, writing in the 1929 edition that the odds of his theory being wrong are 1 in a million. The new expedition is plagued from the start. Bad weather pushes Wegener and his team over a month behind schedule as they rush to establish 3 bases before winter. On September 21st, Wegener sets out to resupply one of the bases. The temperature is minus 60 degrees. The 200-mile journey is planned for 20 days. It takes 40. Most of the supplies are lost in blizzards.
He said to his closest friend, this expedition is now nothing but a matter of life and death. And then the guy who lived for many years afterward and told this story often said, and then he did something that I'd never heard him do before. He talked about how he felt about the world. All I'd ever heard him do was sort of laugh and smoke and do science. And Wegener said, look, it doesn't matter what happens to individuals. He said, science is a social process. It happens on a time scale longer than a single human life. If I die, someone takes my place. You die, someone takes your place. What's important is to get it done.
After a day of rest, Wegener and his Eskimo guide try to return to their own base. They are never heard from again.